Hi scientists, welcome to part 3 of our exploration into gravity. The funny thing is, after I made the first 2 videos, I found out I had even more questions than I did when I started with, especially because in the last video we started to talk about space and what happens to gravity in outer space, and especially when things fall, because as we learned, if there's no air, then a hammer and a feather can fall at the same speed. So once you leave the Earth's atmosphere, there's no air. There's just lots and lots of that vacuum space. But what happens there? Certainly places like the moon have gravity and the other planets have gravity. It just brought up so many questions. Here's some of my questions. What is outer space? Where does it start? When does gravity stop working? How strong do you need to be an astronaut? How far can you jump on the moon? How much do I weigh on the moon? I don't know if I'm going to get to all those questions, but let's start talking about gravity in outer space. Outer space, or just space, is everything that exists outside of our Earth's atmosphere. There's no sharp line that says Earth atmosphere, outer space. What happens is, as you get farther and farther away from Earth, our air in our atmosphere gets thinner and thinner and thinner until there's none left. That's outer space. So what's that halfway point kind of between where there's no air and where it starts to thin? That's about 62 miles off the surface of the Earth. So if you got in your car and you drove straight up for about an hour, you would kind of get to where outer space is starting to happen. You can't do that for other reasons. You need a rocket to leave the Earth. But that's about how far it is. Think about that, getting in your car, driving for an hour. When does gravity stop working? It's a big question, but you've seen when astronauts get in a rocket and they weigh just the same as you or I do, and they're being held down by the Earth's gravity, and they get in the rocket and they take off and it goes up for a little while, and then pretty soon they start to feel weightless. What is that point? It's about the same point where the atmosphere starts to loosen up, about 62 miles off the Earth. But it's important to understand that you can't go anywhere in the universe without feeling some kind of gravitational pull. What happens is the force just becomes so little that you don't really feel it. What's that feeling of weightlessness like? Well, you float around and nothing's pulling you down, nothing's pulling you in any direction. You're just kind of there. If you had a ball and you held it up in the air and you let it go, it would just stay there. Here's a really interesting fact. You don't have to be strong in outer space. You know why? Because your muscles don't really do anything. If everything is weightless, it doesn't really take any effort to pick it up. So what happens to astronauts after they've been in space for a long time? Of course, they need to be in good shape, but they don't have to be weightlifters or anything. While in space, they do training to keep their heart in shape, but they really don't need big muscles. What does happen to your muscles in space? Well, anybody who's in space for a long time loses a lot of muscle mass, and when they come back to Earth, they're very, very weak and need to do a lot of training. What about the moon? We know that in the late 1960s and early 1970s, astronauts went to the moon and walked around on it. Well, what did they feel? Well, they didn't float off into space, so the moon definitely has gravity. It has a lot less gravity than the Earth does, though. If you were to look at the size of the Earth, this would be about the size of the moon. Now, of course, it's much, much farther away. Something like that, maybe. The moon is about a quarter the size of the Earth, more or less. It has a lot less gravity because it has a lot less mass. The more mass you have, the more gravity you have. Your weight on the moon is about 1/16 of what it is on the Earth. So let's do a little math here to figure out what your weight would be on the moon. You're going to need a calculator for this. First, you need to know how much you weigh. So if you don't know how much you weigh yourself. So let's say you weigh 55 pounds. You're going to take 55 and multiply it times 0.165. It's very important when you put it into your calculator, 0.165. So let's do that. I'm going to take my calculator and I'm going to put in 55 times 0.165 5 equals 9 pounds. Can you see that? Can you imagine only weighing 9 pounds? That's how much a little tiny baby weighs. So if you went to the moon, just think how strong you'd be, because your muscles are ready for Earth. But on the moon, you would be able to do so much more. If you're on the moon and you jump, did you know that you could jump 4 times higher than you could on Earth? So do some math. If a basketball player can dunk on 10 feet, which is the rim height for a basketball hoop, how high would the basketball hoop have to be on the moon? Let's see how high I can jump. I can jump probably 1.5 feet. Let's see. I wonder how high I could jump on the moon. Let's do a little more math. Let's try and figure out how far you could jump on the moon. The first thing you need to do is figure out how far you can jump. So get that tape measure out, put it on the floor, pull it out to however far you think you can go, and then stand at one end of it and jump. See how far you jumped. If you can jump 36 inches, we're going to take that number and we're going to multiply it times 4. So you can take your calculator. 36 times 4 equals 144 inches. How far is 144 inches? That's 12 feet. Can you imagine jumping 12 feet? That's like jumping from one side of the room to the other. Hey friends, I hope you had fun thinking about gravity in outer space and gravity on the moon and what it would be like to be there. Maybe some of you will have the chance to go to outer space. You gotta study a lot though. Astronauts don't have to be strong, but they are really smart. So, have fun and I'll see you next week. Bye.